Electrons are much smaller than protons and neutrons, but they are responsible for many things we see in chemistry, such as the bonding of atoms to one another to form compounds. Those are covalent bonds. The interactions of visible light with molecules to produce the colors we see. Those are the electrons changing energy states. Electrons are even responsible for weak connections between molecules and the boiling points of pure substances. The connections between neighboring molecules are called intermolecular forces, and while much weaker than the connections between atoms within a molecule, the covalent bonds, IMFs play a big role in the phases of matter. Compounds that have weak IMFs form gases at room temperature and pressure. Stronger IMFs can form liquids, and molecules with very strong intermolecular forces can form molecular solids, even at room temperature and pressure. Remember that changes of phase are physical changes. So we're not breaking chemical bonds, we're not rearranging the atoms in our matter. What we're doing is we're actually separating the molecules from one another. So phase changes involve pulling molecules apart, and we have to overcome the connections between them, which are the IMFs. In chemistry, we like to measure the temperature needed to make a substance change phase. Like the freezing point, that's going from a solid to a liquid. Boiling points, going from a liquid to a gas. How much energy is needed to separate molecules from one another is directly related to how strongly connected a molecule is with its neighbor. For example, let's look at the halogens. Bromine gas, Br2, is a nonpolar molecule with a dominant intermolecular force of dispersion because it's nonpolar. And the same thing can be said for its neighbor on the periodic table, chlorine, Cl2. But bromine is a liquid at room temperature, while chlorine is a gas under the same conditions. That is because bromine is larger. It has more electrons than chlorine, and so it experiences a stronger dispersion force. Bromine has a higher boiling point than chlorine because it has a stronger IMF. Another great example is comparing polar molecules like formaldehyde with water. Water has a much higher boiling point, 100 degrees Celsius, compared to formaldehyde, which is negative 19 degrees Celsius. And despite being a bit larger, formaldehyde has weaker intermolecular forces because its dominant force is a dipole-dipole force, while the dominant intermolecular force for water is hydrogen bonding. Hydrogen bonding is the strongest IMF, so molecules capable of hydrogen bonding will have higher boiling points when compared to similarly sized polar and nonpolar compounds. If you enjoyed learning about intermolecular forces, check out my other video on hydrogen bonding.